One more example for collision. Here we have this particle which we are releasing it from height of h. So it's gonna come down and hit the ground and then go up, come back and hit the ground and go up again. And after two collision with the ground, the maximum height after the second collision is gonna be h2. The movement in the x direction of this particle is negligible, but to show this path, the problem is showing a slight movement in the x direction, but it is negligible. So just assume this particle is moving just in the y direction. And the problem says if we know the initial height and h2, what's going to be the coefficient of restitution? Can we find the coefficient of restitution by measuring h2 and h1? That's the question. I would suggest to think about this problem for 10 minutes before seeing the rest of this video. So coefficient of restitution comes, we have an equation for it for the impact, right? So for example, in the first collision, coefficient of restitution, based on the definition of it, it's equal to relative velocity of separation divided by relative velocity of before impact. So before impact, the velocity of the particle, if you release it from the height of h, immediately before the impact, velocity of it is going to be equal to root square of 2gh. Why? I will let you to think about it. So velocity before impact, I'm going to call it v1, is going to be equal to root square of 2gh. You can use work energy equation between this point and also this point before impact. And velocity of it after impact, let's call it, is equal to v1 prime. For collision, we need two materials, right? It happens between two bodies. The first body is this particle, and the second body is ground. Velocity of the ground is not going to change before impact and after impact. It's going to be equal to 0, right? So coefficient of restitution is going to be equal to the relative velocity after impact is going to be v1 prime minus 0, divided by relative velocity between the particle and ground before impact is going to be just this v1, which is equal to root square of 2gh. In the second collision, the velocity of the particle before impact is going to be the same as v1 prime. Why? Again, work energy equation. The kinetic energy of this particle before impact, after impact at this point, and the kinetic energy of this particle right before the impact, they're going to be equal because we are not losing any energy during this movement, right? We have conservation of energy. Potential energy of the particle in these two conditions is the same. So the kinetic energy of them is going to be equal to each other too. And because of that, the velocity is going to be the same for both of them. Velocity of it after impact, after the second impact, is going to be a different number. Let's call it v1 double prime. And we can use the same equation for the second impact because the material is not changing. So the coefficient of restitution for the second impact is going to be E again. E is going to be equal to relative velocity after impact, which means v1 double prime minus velocity of the earth, which is 0, divided by the relative velocity before impact, which is going to be v1 prime. And so we have these two equations. And if I multiply these two equations together, I'm going to have E squared. v1 prime is going to cancel out. And we are going to have v1 double prime divided by root square of 2gh. But we know what is h2. I don't know what is v1 double prime. But we know there is a relationship between h2 and v1 double prime. What is the relationship between this velocity after impact and the maximum height? Again, you can use work energy equation between this point and this point after impact. So the kinetic energy after impact here, which is 1/2 of mass times velocity squared, is going to be equal to the potential energy here. There is no kinetic energy here, right? And there is no potential energy here if you assume this is my reference line. Potential energy here is mgh2. M is going to cancel out. So V1 double prime is going to be equal to root square of 2gh2. So if I replace this V1 double prime here in this equation, then I'm going to have E squared is equal to square root of 2gh2 divided by 2gh. It's going to be h2 divided by h. Or E is going to be equal to fourth root of h2 divided by h. So we found the coefficient of restitution in terms of h2 and h.